Hello everyone. Today we will discuss some important properties of the vectors. The first property is that the vectors in addition follows the commutation law, and we can write as vector A plus vector B is equal to vector B plus vector A. Now here in the diagram you can see that there are two vectors. This is vector A and this is vector B. Here if I add vector B in vector A, then I will get an output or a resultant vector that will be equal to A plus B. Now see here, first I draw the vector A. This is the tail of the vector A and this is head of the vector A. Now I draw the vector B from the head of the vector A, so it is your vector B. Now if I want to find the resultant of these two vectors A and B, then it will be equal to vector A plus vector B. Now if I follow the other order, because it is vector B, if I draw a vector here, then because it is parallel to this vector, so we can say that it is vector B. Similarly here this is your vector A, then I draw a vector A here because it is also parallel to this in terms of the magnitude and direction, it is same, so I will consider it as vector A. Now this is your vector B and this is your vector A. Now if I add the vector A in vector B, then you will see that it is your vector B and it is your vector A. So we will find here the resultant, that will be vector B plus vector A. So you see here that when I follow the order clockwise, then our resultant is vector A plus vector B, and I follow the anti-clockwise order, then our vector B plus vector A has the same resultant vector as the vector A and vector B. So we can say that in case of the addition, the vectors follow the commutation law. Now similarly here, uh, in case of the association law, when we add three vectors, then we get the same resultant as an output. Here you can see that there are three vectors. This is your vector A, this is your vector B, and this is your vector C. Now if I add vector B and vector C in vector A, then we will have an output here, vector A plus vector B plus vector C. This is the green vector represent the resultant vector of vector A and vector B and vector C. Now this is your vector A, this is the tail of the vector A, this is head of the vector A. Then this is your vector B, this is the tail of the vector B, and this is head of the vector B. Now this is your vector C, this is the tail of the vector C, and this is head of the vector C. Now I match. In addition, you know that tail is matched to tail and head is matched to head. So the green vector represents the resultant vector of the three vectors A, B and C. Now we can add these three vectors in a different way also. Now see here, this is your vector A, this is your vector B. So we can draw a vector which will give you an output vector A plus vector B. This is your vector A, this is your vector B. So this vector will be your vector A plus B. So this is your vector A plus B, then this is your vector C. So you will see that you will have the same vector, vector A plus B plus vector C, which is in result is equal to the earlier vector. Similarly, here this is your vector B, this is your vector C, so this will give you the vector B plus C. Now this is your vector A, this is your vector B plus C, so your output here will be vector A and then vector B plus vector C. So again you are getting here the same resultant. In case of the association law, for addition of the vectors, we can use bracket anywhere in the three vectors. Now see here, first I use the bracket for the first two vectors, then here you can see that I use the bracket for the last two vectors, and the sum of all the three vectors are same. So this is the association law of the vectors. Now we will discuss about the vector and scalar quantities. As earlier we have defined that scalar quantities are those quantities which have only the magnitude. But in case of current, sometime it may be confusion that because current is represented by sometime in terms of the magnitude as well as in terms of the direction, but it cannot be considered as a vector quantity because it does not follow the law of the parallelogram. Here you can see that there are two wires in which a current of 3 ampere and 4 ampere is flowing, and the important thing is that the two wires here are perpendicular to each other. So if we want to find the resultant of the current for these two wires, then I take a third wire. So you know that in this wire the current will be 7 ampere because 3 plus 4 is equal to 7. This is the algebraic sum of the 3 ampere and 4 ampere, which is equal to 7 ampere. But in case of the vector quantities, you see here that, let us say here a velocity is 3 meter per second. This is the direction notation. This is your east side, this is your west side, this is north side, this is south side. So here velocity is in east direction and its value is 3 meter per second. The other velocity is 4 meter per second. Its direction is in north side. So here you can see that the two vectors are perpendicular to each other. So when we find the output of these two velocities, then our resultant is 5 meter per second. It is not 7 meter per second. So in vectors, we cannot obtain 3 plus 4 is equal to 7 until the condition is specified. So here velocity will be considered as a vector quantity and current is considered as a scalar quantity. Now I will discuss the law of the parallelogram. Now what is the law of the parallelogram? If the two adjacent sides of the parallelogram are represented by two vectors, this is your vector A and this is your vector B, then the diagonal of the parallelogram will represent the resultant of the two vectors A and B. So it will be equal to vector R is equal to written as vector A plus vector B. Now in terms of the magnitude, we can find the value of the resultant vector. Let us say OA, it is your vector A, and OD, this is your vector B. These two vectors are inclined at an angle of theta. Now I draw a line AB. This will represent the vector B because it is parallel to the OD line. Similarly, I draw a line DB. It will be represented by vector A because it is parallel to OA. So this is your AB is your vector B in terms of the magnitude, and this is your DB is your vector A, right? Because this angle is your theta, so if I draw this OA line further in positive x direction, then AB will make an angle of theta with the OA line. Now I draw a perpendicular from B to OA line. Let us say BC is perpendicular to O, means this angle is your 90 degree, right? So now we can find the value of the cos theta and sin theta from this triangle ABC. Now see here, cos theta will be equal to AC upon AB, and AB in terms of the magnitude will be written as B. So it is equal to B cos theta. Similarly, if we take sin theta in this triangle, then we will have sin theta will be equal to BC upon AB. So here BC will be equal to B sin theta. So here you can see that we have found the value of the AC and the value of the BC. Now if you see the triangle OBC, it is a right triangle, so we can use the Pythagoras theorem. So in that triangle, you know that you will have the OB whole square is equal to OC whole square plus BC whole square. Now see your OC is equal to OA plus AC. So OC is equal to OA plus AC. OA is your A and AC is your B cos theta. So OC will be equal to A plus B cos theta. BC is equal to B sin theta. So now we can write it as R square is equal to A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. So here is B cos square theta. Here we have B square sin square theta. So cos square theta plus sin square theta will be equal to 1. So here your R square will be equal to A square plus B square cos square theta plus sin square theta plus 2AB cos theta. For your R square will be equal to A square plus B square plus 2AB cos theta, or R will be equal to root A square plus B square plus 2AB cos theta. So here you see that if your theta is here 90 degree, then you know that cos 90 is equal to 0. So here your resultant will be 3 square plus 4 square. 3 square means 9, 4 square means 16. So 9 plus 16 will be equal to root 25, and it will give you the resultant 5 meter per second. So in case of scalar, you see that your 3 plus 4 is equal to 7, but in case of the vector, your R is your resultant 3 plus 4 is equal to 5 when your theta is 90 degree, right? So in case of the vector quantities, you cannot write in terms of the magnitude R is equal to A plus B, but you can write vector R is equal to vector A plus vector B, but you cannot write R is equal to A plus B. These terms are in terms of the magnitude. These values are in terms of the vector quantities, right? You know that the magnitude of the vector will be represented as R, right? Similarly, the magnitude of the vector A will be represented as A. Similarly, magnitude of the vector B will be represented as B. Then we will discuss the other properties of the vectors. Thank you.